As we progress through our differential equations course together, it's going to become clear at times that algebra is possibly the most important part of your mathematical preparation for this course. Now, if it's been a while since you've done algebra in a formal algebra class, don't worry. Throughout your Calc 1 and Calc 2 classes, you also were doing algebra along the way. And a lot of that algebra will continue to be used in our differential equations course. In order to review some algebra stuff all in one example, I'm going to go through an example of a partial fraction decomposition. Let's take a look at the example of x plus 14 divided by the quantity x squared minus 2x minus 8. Now, if we wanted to do any kind of calculus with this, we would have to use the quotient rule to take a derivative, and we would have to do some substituting if we wanted to integrate. So partial fraction decomposition is an algebra tool that allows us to make this look a little bit nicer and easier to approach with our calculus techniques. So basically, partial fraction decomposition is the opposite of finding a common denominator and combining fractions. So we want to be able to pull apart fractions. So what we want to do is we want to see if our denominator can actually be factored to begin with. So off to the side here, I'm going to look at x squared minus 2x minus 8. And I'm going to decide if I can factor it. And after looking at it a little bit, you might see that we actually have x minus 4 times x plus 2 as our factored form of x squared minus 2x minus 8. So since I can factor my denominator, I'm going to rewrite my fraction with the factored denominator. So I have x plus 14 over x minus 4 times x plus 2. Now, what partial fraction decomposition says is, hey, you have something that has a denominator of these two pieces being multiplied together, so we should be able to break that up and say this is really some value over the first part plus some value over the second part. This would have been how we had two separate fractions, and then we decided we wanted one fraction, so we came up with that common denominator of the product of the two denominators that I have, and then my numerators would have combined to make x plus 14. That's the idea here. So we want to figure out, well, what would a and b have to be? So what we're going to do is we're going to recreate the idea of what happened to get from a over x minus 4 plus b over x plus 2 to get to this combined fraction of x plus 14 over x minus 4 times x plus 2. So the thing that happened to do that is we multiplied by both sides by x minus 4 times x plus 2 to give us that common denominator. So we're going to multiply both sides by our common denominator again. Multiplying the left side by x minus 4 times x plus 2, I'm left with x plus 14, just my numerator. Multiplying the right side by x minus 4 times x plus 2, I get that the x minus 4 cancels out in the a term, so I'm left with a times x plus 2 plus, and on the b term, the x plus 2 canceled out, so I'm left with b times x minus 4. So now that I'm at this stage, I can multiply a times x plus 2, multiply that out, and get that this equals ax plus 2a. And I can do the same thing distributing the b to the x and the minus 4, getting bx and minus 4b. Now I'm going to rearrange this a little bit and get my x terms together. So I have ax plus bx and my constant terms of 2a and 4b left off to themselves. And now I can look and I can notice that I have an x term on both sides and I have a constant term on both sides. So in order for this equation to work out, I need my x terms to be equal to each other. So my x terms, I'll have x equals ax plus bx. And since every term here has an x in it, I can actually divide by x and all of the x's go away, leaving me with 1 equals a plus b. And then in my constant terms, I'll have 14 equals 2a minus 4b. So at this point, what I have here, with 1 equals a plus b and 14 equals 2a minus 2b, this is a system of equations. So I'm going to write them over here together. So I have 1 equals a plus b, and 14 equals 2a minus 4b. Now, you can solve this system of equations using whatever your favorite technique is. You can use elimination, you can use substitution, you could even use a matrix if you'd like. All right, so I'm going to use substitution. I'm going to notice that the first one tells me that a equals 1 minus b. And then I'll substitute 1 minus b in for a into my second equation. So I have 14 equals 2 times 1 minus b minus 4b. And now I can distribute the 2 and I'll get 14 equals 2 minus 2b minus 4b. Subtracting the 2 to the other side, I'm left with 12 equals minus 2b minus 4b is minus 6b. And that's going to lead me to have b equals negative 2 when I divide by negative 6 on both sides. So since b equals negative 2, then I'm going to go back to my a equals 1 minus b and plug that in. So I'll get a equals 1 minus a negative 2. And minus a negative is addition, so a is going to equal 3. So now I know, going back to my original equation, that this is actually equal to 3 over x minus 4 plus minus 2 over x plus 2. Alternatively, you could put the negative that's in the numerator, where the b is, down and have it be minus the fraction 2 over x plus 2. Either way is correct. So that is my partial fraction decomposition. And now that's a much nicer setup to do calculus techniques with. Now you may be thinking that it's not always that simple, or hopefully you're remembering times when it wasn't quite that simple. And it's true, partial fraction decomposition can get more complicated when there are repeated roots in our denominator, or if we have a chunk of our denominator that we can't actually factor out to these linear terms. And so I really want to encourage you to go back and take a look at partial fraction decomposition a little bit deeper than this. But hopefully this gave you a little bit of a push and dusted off some cobwebs.